Right. Hello, everyone. Today we are going to be studying or learning about the greatest common factor and also factoring by GCF, which is factoring by the greatest common factor. The whole lesson is a little bit challenging, so please stay with me and please go step by step. Remember, when I tell you to pause, you want to pause and try the problem on your own before continuing. So let's start with a story. Billy, Jaden, and Eric, they all decided they want to go to the mall. So they go to the mall, right? While they're walking around the mall, eye shopping, they realize they're hungry and they go to the food court. So when they get to the food court, they want to buy maybe a pizza, maybe something. So they look in their pockets and find out how much money they have. Billy reach in his pocket and realize he has $12. Right? Billy big balling. So then we have Jaden. Jaden looks in his pocket and he realizes, oh, I have $9. And then Eric looks in his pocket and he realizes, man, I only have $5. Now, if they're all going to go buy a pizza, right, and they're all going to eat the same amount of pizza, chances are they all want to put in the same amount of money, right? Because Billy, big baller, isn't going to pay for the entire pizza and Eric keeps his money and Jaden keeps his money. No, you want to put in the same amount. If they all want to put in the same amount of money, can they put in $12? No, because Jaden doesn't have $12 to give and Eric doesn't have $12. He only has $5, right? So they don't have enough. Can they all give $9? No, Jaden can give $9 and Billy can give $9, but Eric does not have enough. Well, what about $5? That's what Eric has. Yes, they can all give $5. Eric can give 5, Jaden can give 5, and Billy can give 5. Now, when Eric gets 5, he doesn't have any more left over. He's broke. Jaden can give 5, and then he'll have $4 left over. That's fine. Billy can give 5, and then he'll have $7 left over. That's fine. So they'll have some extra money, and Eric will have no more money left. But they can all give 5. The amount they give is going to depend on Eric because he has the lowest amount. All right. We're going to use that concept as we go along. So here we're going to first find the greatest common factor of numbers. The greatest common factor of 24 and 60. Well, you have to find the factors of 24, which would be 24 times 1. Maybe you have 12 times 2, 8 times 3, 6 times 4, no 5, 4 times 6. Okay, so these are your factors of 24. Factors of 60, you have 1 times 60. What else will give us 60? 2 times 30, 3 times 20, 4 times 15. And if you notice, I'm kind of going 1, 2, 3, 4. That's because it helps me with the factors. That will also help you with the factors so you don't miss any. 60, 1, 2, 3, 4, 5. Oh yeah, 5 times 12. You have 6 times 10. I think I've got my answer. All right, so now we look and we tell, well, what could be the greatest number they have in common? Yes, they have 2 as a factor, but 2 isn't the greatest. Yes, they have 4 as a factor in common. They have 2 as a factor in common, but it's not the greatest. They have 4 as a factor as a common, but it's not the greatest. 6 is a factor they also have, but not the greatest. The greatest common factor is one of these bigger numbers here. It's going to be 12. 12 is the biggest number they both have in common. So it's the greatest common factor. The answer is 12. Let's look at 18 and 27. What would be the greatest common factor? Factors of 18, 2 and 9. Oh, 1 and 18. 3 times 6 is 18. Okay, I think that's it. Factors of 27, that's going to be 1 and 27, not 2, because that's an odd number. 3 and 9, 4, 5, 6, 7, 8, and then 9 again. So those are my factors of 27. If you could hear me, I'm actually doing multiplication in my head. You also need to go through that process. What are the factors? Now, what is the greatest factor they have in common? They might have 3 in common, yes, but that's not the greatest common factor. The greatest one they have, not 27, because that doesn't even have it, would be 9. Now pause and do number 3. So now that you've paused for 15, you should have 1 and 15. You should have, oh, sorry, I almost did 2. 3 and 5, 4, 5. And that's it. For 25, you would have 1 and 25. You would have 5 and 5. 2, not 3, not 4. That's it. So the greatest common factor is 5. Now remember when we talked about Eric, Jaden, and Billy? And the greatest they could give was 5 because that's what all of them had in common. That's what's going to play a role here when we factor the greatest common factor of monomials. Just like when we multiply, we're going to do the numbers first. So the greatest common factor between 3 and 6 is going to be, well, it's 3 times 1. So numerically, the greatest common factor numerically is going to be 3. Now we have to check the variables. Well, this one has x to the third power. It has 3 x's. And this one has x to the second power, which means it has 2 x's. Well, how many x's can they both give? This one can't give 3 because it doesn't have it. But it could give 2, and that could give 2. So now we have 3x. That's what they both have in common. In essence, you can tell the amounts that you can give based on the numerator. I'm sorry, based on the exponent. If this has 3 x's and that has 2 x's, they can only give 2 x's, the lower number, because that's what they can both give. Oh, I have x, sorry, my answer is x squared. Let's look at number 2. We have 4x squared and 8y3. Remember, numbers first. So between 4 and 8, my greatest common factor is 4. And then I have x squared and y3. This one has 2 x's, and this one has 3 y's. Well, if this has 2x and this one has y, they can't give any of them, right? Because they're not the same. So the greatest common factor is just 4. Go ahead and try number 3. All right, now that you have paused and tried number 3, here's your solution. So the factors of 18, the greatest common factor between 18 and 27. I know 18 has, again, 1 and 18, doesn't make a difference. 2 and 9, 3 and 6. And if you are good and you can recognize right away that 9 is the greatest thing that they both have in common, then you are good to go. This process is just to help you if you don't know. So numerically, 9 is the greatest factor. And then between g squared and g3, this one has 2 g's to give, and this one can give 2 g's and have 1 left over. So the greatest common factor you could factor out will be g squared. 9g squared is the answer. So now let's use that same concept, and we're going to factor out the greatest common factor of expressions. So here we are. We have 5x to the third. Technically, there's only one of them. And 25x plus 3 to the third. Always remember, numbers first, or coefficient first. So first, you're looking at the 5 and the 25. Well, what's the greatest common factor between 5 and 25? It's evidently going to be 5. Now, what's the greatest common factor between x plus 3 and x plus 3 to the third? This one only has 1, and this one has 3 to give. So, like Eric again, he has to give, everybody gives according to him because he has the lowest amount. So your greatest factor here is 5x plus 3. You try number 2. Pause and try number 2. Now that you have paused, you would have gotten the greatest common factor between -8 and 16 is going to be 8. Or you could have -8 as well. If this is m plus 1 to the third, and this is m plus 1 to the sixth, well, they can both give 3. So this is m plus 1 to the third. That's what they both have in common. So now let's factor the polynomial. So far, we've only figured out what the greatest common factor was. But if you recall in the top, once Eric gave his $5, he had $0 left. When Jaden gave his $5, he had $4 left. And when Billy gave his money, he had $7 left. So there are leftovers. When we factor polynomials, we're going to factor out what they have in common, but we also have to account for the leftovers, almost like division. So let's look at number 1. We have 4x squared minus 3x. Numbers first. Between the 4 and the 3, the only thing they're going to have in common, or their greatest common factor, is going to be 1. And you could always do that to the side. So we have 1 that we're factoring out. Then they have x squared on the 4x, but then this is just an x and x to the 1. That means the only thing I can factor out is that x. So the greatest thing they have in common is x. Now let's talk about the leftovers. 4 and 4 divided by 1 is still 4, so 4 is left over. And then if I take 1x out of x squared, I'm still going to have an x left. Minus 3 divided by 1 is 3. And I have an x that I took out, so I no longer have it here. I'm done. So my answer is x times 4x minus 3. Now to check it when you factor, you can always multiply. Let's go ahead and check our work. If I have x times 4x minus 3. X times 4x is going to give me 4x squared. I could have done that in another color. And x times negative 3 is going to give me negative 3x. Well, is this where I started? Yes. I know I factored it correctly. It's the opposite of multiplication. Let's look at number 2. So, numbers first. Factoring is like division, right? It's the opposite of multiplication. So we have 10y to the third plus 20y squared minus 5y. So for the 10, 20, and 5, I'm going to think what is the greatest common factor 10, 20, and 5 have together? Well, I know, first of all, that the only way to get 5 is just 5 times 1. That means let's look at the other two numbers and see if 5 is a factor. Is 5 a factor of 10? Yes, it's 2 times 5. And is 5 a factor of 20? Yes, it's 4 times 5. So numerically, the greatest common factor is 5. Now look at the variables. After you look at the variables, this has y to the 3, y to the 2, and just y, which means it's y to the 1. Well, how many y's then can we take out from all three of them? Correct, 1 y. Now let's look at the leftovers. If I took the 5 out, 10 divided by 5 is 2. 2 is left over. I have 3 y's, and I took 1 out. So now I have y squared. 3 minus 1 is going to give me 2, plus sign. Then I have 20 divided by 5. I took 5 out of there. 20 divided by 5 is 4. Y squared, I took an y out, so now I'm left with y. Minus sign. 5 divided by 5 is 1. And then I took a y out, so I have no y's. I have factored my polynomial, the opposite of multiplication. So again, to check my work, I can go ahead and multiply. I'm going to check it with blue. So if I have 5y times 2y squared plus 4y minus 1, 5y times 2y squared, 5 times 2 is 10. Y times y squared is y3. Plus 5 times 4 is positive 20. Y times y is y squared. And then 5 times negative 1 is negative 5. And y, there's no y, so we got 1 y here. Is this where I started? Yes. I am done. I'm going to do one more with you, and I'm going to make that one number 4, only because I also want you to see it with a negative coefficient. So if I'm doing number 4, again, numbers first. If you're factoring out and your leading coefficient is a negative number, you want to factor out the whole negative with whatever you factor out. So for example, we have negative 4 y4 plus 6y squared minus 14yx. Well, numerically, numbers first, What is the greatest common factor between 4, 6, and 14? Well, they're all even numbers. I give you that. And I know the factors of 4 is 4 and 1. Well, 6 isn't divisible by 4 or 14. So I know, okay, can't be those. But they're all even, so maybe it's going to be that 2. So we have, how do we get 4? It's 2 times 2. A negative 2 times a positive 2. How do we get 6? It's 2 times 3. Positive. How do we get negative 14? It's 2 times 7. That's how we get 14. And the sign here, negative, only because I'm going to have to factor out a negative 2. And then the 6, I'm going to factor out a negative 2 as well. If I factor out a negative 2, that has to be a negative 3. So numerically, I'm going to factor out a negative 2. I'm factoring out 2 because they're all even, but I also have to account for that negative sign. I got to factor it out if I can. So now I look at the variables. After the numbers are the variables. This one has y4, y2, and this one has a yx. Well, technically it has a y to the 1 and an x to the 1. Do they all have a y? Yes. So we're going to factor out the y's. Factor out 2y. Now what's left? Numbers first. Negative 4 divided by negative 2 is going to give me positive 2. Y4 divided by y1. I took one y out. Subtract when we divide will give me y3. Negative 6 divided by negative 2 is going to give me negative 3. And again, that's what I have left over here numerically. Y2 divided by y1 is y. Negative 14 divided by negative 2 is a positive 7. And I took a y out, so all I'm left with is an x. And then you can go ahead and multiply to check. I know this was a little confusing. You could go ahead and replay it. And then I want you to pause and try number 3 and number 5. Remember, we're going to try it. All right, now that you've tried it, let's look at number 3. Numerically, between the 18 and the negative 7. 18, I know I have 2 times 9, 3 times 6. 7 is just 1 and 7. So numerically, I know there's no factor except for 1. 1 and 18. This happens to be a negative, though, so I do want to take the negative out. I'm going to take out a negative 1. This has y3, and this has y2. So they both have 2 y's to get. I'm going to take out the y2. I could take out the y2 and still have enough left over. So I have negative 1, y2. Now the leftovers. Negative 18 divided by negative 1 is positive 18. Y3 divided by y2 is y. Minus sign. Nope, not minus sign, because I'm going to divide the negative 7 by negative 1. So I get a positive 7. And then y2 divided by y2, the y's are gone. So to clean this up, my answer is negative y squared times 18y plus 7. And again, feel free to multiply, distribute, multiply in order to check it. For number 5, you should have been like, oh my God, this looks hard, but that's okay. It's just a challenge. Start with numbers first. So we have 24, we have 30, and we have 12. Well, what is the greatest common factor between all of those? I know for sure with 12, I'm going to have 1 and 12. 3 and 4, 6 and 2. Yeah, that's it for 12. So then between those, let's see, 12. Is 30 divided by 12? No, 24 is, but not 30. So it can't be 12. Next biggest number is 6. And maybe I should point that out. I tend to look at the lower number because it's easier and because it has to be the greatest common factor coming from there too. So once I use the lower number and check against the other two, it just made it a little bit faster. That's another strategy. So 12 is divisible by 6. 30 is divisible by 6. And 24 is divisible by 6. So 6 is going to be my greatest common factor. I know this is going to be a 6 times 2. This is going to be a 6 times 5. And it's going to be a 6 times 4. Do you need to do that? No. I just do it to help you out. But if mentally you can go ahead and divide, you're okay. So here we go. We know numerically then that the greatest common factor is 6. Now let's look at the variables. This has x3, this one has x2, and this one has x2. Well, what's the greatest amount that you can take from either the x's? That would have been x squared. And then we have y4, y3. Let me get another color for the y's. We have y2, y3, and y4. Well, the lowest amount you could get from the y's is y2. They each have 2 y's to give, so y squared. Now for the leftovers. 24 divided by 6 is 4, so 4 is left over. x3 divided by x2 is x1, so just x. y2 divided by y2, no more y's. Minus sign. 30 divided by 6 is 5. X squared divided by x squared is no more x's. y3 divided by y2 is y. Plus 12 divided by 6 is 2. X squared divided by x squared, there's no more x's. And y4 divided by y2 is going to give me y2. There you go. I have factored my polynomial, which is really a, what's that? A quintic trinomial. Now let's keep going. This is a long one. That's okay. We're now going to factor out a binomial factor. That means if they match, you take them out. The leftovers become their own. So if I look, I see 7, x minus 3, that's a binomial, minus 2x times x minus 3. Well, the x minus 3 matches the x minus 3. It's going to become its own factor. The leftovers, which is the 7 and the minus 2x, actually becomes its own factor. That's how we factor out a binomial factor. That was weird, huh? Let's try it again. I have 3x squared times x plus 2 plus 4 times x minus 7. So I want to look. These have to match. The binomial have to match in order for you to factor it out. The x plus 2 and the x minus 7 does not match. So this is what's going to be called not factorable. I can't factor it. Now, please keep in mind, this is not used very often. Not used very often. So don't go around, not factorable, not factorable, not factorable. No, you're going to do your best to factor it because that occurs very rare. Okay. Now let's look at number 3. For number 3, I want to factor out a binomial factor. It's a little tricky because At first glance, these do not match. It's an x plus 4 and a 4 plus x. But in reality, it does. Because this is 9x, x plus 4, plus, if I rearrange that within the parentheses, 4 plus x is the same as x plus 4. And now they would look like they match. But all I did was rearrange what's in the parentheses. Because they match, that matches with that, it becomes its own binomial. And the leftovers become its own binomial. Now you might be like, well, where's the other one for the binomial? It's here. I don't have a number, which means the number is 1. That's how we factor out a binomial factor. We use that a lot because we factor by grouping. To factor by grouping, you must start in standard form. And it must have 4 or more terms. If it's a trinomial with just 3 terms, you can't factor by grouping. It's not enough to group. All right, so to factor by grouping, we need 4 or more terms. Let's look at number 1. We're going to write this equation first in standard form. 12a3 minus 9a2 plus 20a minus 15. Yes, 3, 2, 1, 0 on the degrees. It is in standard form. So then, step 2, we're just going to group it into 2 and keep that sign in front of it. Now I have 2 groups. So then I'm going to factor each group, each binomial group. So we have 12a3 minus 9a squared between 12 and 9. And this uses a lot of our multiplication skills. Between 12 and 9, the greatest common factor is going to be 3. Because 3 times 4 is 12, 3 times 3 is 9. It's just 9 and 1. So this is 3 times 3, and this is 3 times 4. That's why I also say if you could do it without that, this is going to be better for you. So we can factor out a 3 from both. I have a to the third and a squared, so I could factor out a squared. What's going to be left over? 4. A to the third minus a squared, so 4a minus 9 divided by 3 is 3. And a squared divided by a squared, it was taken out. That's all I have, 4a minus 3. Now I'm going to factor out the next one. Put this in blue. I think of 20a minus 15. Well, what's the greatest common factor numerically between 20 and negative 15? It's 5. So we have 5 times 20 divided by 5 is 4. And a, oh, I'm sorry, we didn't check the variables. So this one has 1a and this one has no a. I cannot factor out an a. So 20 divided by 5, 5 times 4 is 20, and 5 is 15. 20 divided by 5 is 4, and I didn't take out an a, so I still have an a. Minus sign, and 15 divided by 5 is 3. This is important because these should match. If they don't match, you did something wrong. You have to go back and find it and fix it. 4a minus 3 here should match the 4a minus 3. So together, they become just 4a minus 3. And the leftovers gets their own parentheses. So it becomes here 3a squared plus 5. That is my answer. Now you might say, how does that work, Miss Reed? Let's check it. Let's do 4a minus 3 times 3a squared plus 5. Remember last class? So 4a times 3a squared, 4 times 3 is 12. A times a squared is a3. And then you go 4a times 5. So that's going to give me plus 20a. Then I'm going to come down and do the bottom part. So negative 3 times 3a squared will give me negative 9a squared. And negative 3 times 5 is going to give me negative 15. And then I'm going to be sure to put this in standard form because right now it's not. Highest degree is 3, highest degree is 1, and then 2, then 15. I need to flip it around. So it will be 12a3 minus 9a squared plus 20a minus 15. And is this where I started at the very top? Yes, that is my check. I am correct. Remember, factoring is just division. It's the opposite of multiplication. All right, let's do number 3. Then I'm going to have you try some of the other ones. So I look and I see 3x squared minus 15x squared plus 10 minus 2x. Well, is this in standard form? No. In fact, I do believe I meant to put x3 right here. I do believe this should have been an x3. I'm sorry. Okay, go ahead and fix that on your paper. I believe it should have started off with an x3. Let's try it out. So we have 3x3 minus 15x squared plus 10 minus 2x. So we would put it in standard form first, because right now it's not. So we have now 3x cubed minus 15x squared minus 2x plus 10. Remember, before we work with it, standard form. Then we are going to group it. So now let's factor the first group. 3, greatest common factors, numbers first, between 3 and 15 is going to be 3. And then x to the third and x to the second power, I can factor out an x squared. Then I'm left with 3 divided by 3 is 1. And then x3 divided by x2 is just x. Remember, we won't see the 1, but I want you to see it. And then 15 divided by 3 is going to give us negative 5 here. X2 divided by x2, the x's are gone, so I'm done. On the next one, if we can, we always want to factor out that negative. So between negative 2 and 10, our greatest common factor is negative 2. And left over, we're going to have negative 2 divided by 2, which is 1. I didn't take out an x because this one did not have an x to give. And then 10 divided by negative 2 is negative 5. And then you want to check, do they match? Yes, that is a sign you're on the right track. You did it well. So then your answer is the remaining, which is the x minus 5, and the leftovers make their own. I like to put it in not standard form, but with the higher degree first. Sometimes it's 3x squared minus 2. Your leftovers become their own. This is a leftover. Let me put it together. Becomes its own parentheses. I factored it. Go ahead and try number 2. Pause and try number 2. All right, now that you've paused and tried it, you want to put a parentheses into 2 groups. All right, between 9 and 18, you would have gotten 9 as the biggest factor. Between x3 and x squared, you could factor out an x squared. Then you're left with 9 divided by 9 is 1. x3 divided by x squared is just x. And then 18 divided by 9 is 2. X squared divided by x squared, there's no more. Oh my God, it matches already. I know I'm on the right track. But even then, you might say, okay, I don't have to factor anything out of here. They don't have anything in common. They actually have a 1 in common, which we don't usually use. But because it needs to have a binomial, I need that 1. And then it's x plus 2. So my answer is the matching one, x plus 2, and the leftovers, which is 9x squared plus 1. Doesn't matter which one goes first. No, it doesn't. All right, now go ahead and try number 4. Don't mind this thing here on the top. And number 5. I'll even give you a break on number 6. Whew. All right, so step 1, now that you have finished trying the problem, you want to make sure, again, it is in standard form. And I see different variables. Let's try it out. So let's go ahead and put a group here and a group here. I think I might have been tripping. I don't know. All right, so let's put a group around and let's see what happens. Between 3m3 minus 4m squared, they don't match. Or between 3 and 4, I should say. That won't work. So I could only pull out an m2. That means I'm left with 3m minus 4. And then from the 9 and minus 12, I can go ahead and pull out between 9 and 12. There's a 3. Okay, so I think it should have been an m. I don't know what I did, guys. And then this would be a 3, yes, m minus 4. So this should be an m. Help you make the choice. And now you see, okay, these do match. So your matching one would be 3m minus 4. It gets its own parentheses. And then the leftovers will get their own parentheses at m squared plus 3. Last one. Cross out number 6. All right, so you're going to group it again. Group, 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 group. And we're doing a lot of grouping because grouping will matter more so for the next lesson as well. So we have 2p3 plus 5p2 between 2 and 5 numerically. They don't have anything in common, just the 1. p3 and p2, you factor out the p squared. And now you are left with a 2 p3 minus p2, 2p1. And then you have a plus 5. And p2s came out, so you're good to go. Between 6p and 15, The greatest common factor between 6 and 15 is going to be 3. So it's 2 times 3 and 5 times 3. So then we're going to factor out a 3, and I'm left with 2p plus 5. And there's always a relief when this binomial matches that binomial, because I did it right. So then we have as our answer 2p plus 5. The ones that match makes its own parentheses, and the leftover makes its own parentheses. All right. Thank you all for watching. See you tomorrow.